Okay, so basically this problem is asking a student is running at her top speed of 4.7 meters per second to catch a bus, which is stopped at the bus stop. When the student is still at a distance of 40.4 meters from the bus, it starts to pull away, moving with a constant acceleration of 0.171 meters per second square. So the first thing that we can do to solve this problem is to make a small sketch. And this is going to be our 1D, let's say, line of reference, coordinate system, whatever you want to call it. So I am going to have the student here is a girl, and she's running to catch the bus, which has stopped at this point. So at this point where the girl is standing, on this particular scene of this movie, she's at 0 meters. At this bus is at 40.4 meters. Okay, now we are going to start talking about the givens. We have the girl or the student, and we have the bus. So the given information that we have is that she's running at her top speed. And when they say top speed, they means that she's at the maximum of her speed or velocity. So that implies that first her acceleration is 0 and that her velocity is constant because the acceleration is 0. So we can say that velocity initial is equal to velocity final, and her velocity then is 4.7 meters per second. We also know from this that her x naught or x initial, the point where she is 0 meters, because she's right there and she's trying to catch this bus. Now, the bus has a different givens. We know that it has an acceleration of 0.171 meters per second square. But we know that the bus is stopped at this point. So the velocity, initial velocity of this bus is 0 meters per second. It's not moving. The final velocity is something that we don't know, but at this moment it's not asking us for that. And or it's not giving us that. And it says that in this case the bus when it's stopped is at 40.4 meters, so that makes the x naught for the bus to be 40.4 meters. Okay, so one of the things that we are going to be asked for first is, and these are the answers for my part of the problem, is that we have to find for how much time does the student have to run at 4.7 meters per second before she overtakes the bus. So what they want to know is like how much little, let's name her, and she's like, oh, because she's late for school and her name is Susie. How much Susie has to run to get to the bus? Basically, we want to get Susie from a point here to some whatever point where Susie is at the same point of the bus. This is the same point, and we can call this like x final. So we're going to use the first equation that our teacher gave us, and we're going to say that x final is equal to x initial plus initial velocity plus time times time plus 1/2 acceleration times square. Now, for Susie, we want to get her to a point where the x final of the girl is equal to the x final of the bus, because we want to have them at the same point. And by final, it's not that the world is ending for them at that moment, but it's just our reference point is equal, and we are moving from an x initial to that point, letting us use this kind of equations. So we know that for the bus, dx is basically, we have the same equation, nothing changes. Now I could go on and make this x not bus, but I really don't have time for that. Okay, so we're going to fill this in. Now we have that the x for the girl is, she's at 0, so whatever, this is 0, we don't care about it. Velocity initial is 4.7 meters per second. Time plus acceleration. Acceleration is 0, so we don't care about this. We are done for the final position of the girl. Now for the bus, we know that x initial, where it's starting, is 40.4 meters. And we also know that the velocity is 0, so we don't care about this. And we know that it has an acceleration. So it's 1/2 times 0.171 meters per second square times a square times time square. And basically we make this equal to each other, and we're going to solve for time. And what we have here, if we move all of the terms to the right, is 0 equal 40.4 meters, that takes care of this one, minus 4.7 meters per second, time, that takes care of this, plus 1/2, 0.171 meters per second square times square. We have t squared, t, and some constant. This is the quadratic equation. Now we can spend a lot of time trying to have this baby solved with algebra, but we're not going to do that. We're going to plug this in the calculator. We have 40.4 minus 4.7x plus 1/2 times 0.171 x squared. Let's zoom auto. And I'm sorry you guys are not seeing anything because I was copying the equation. This is what you're going to see now. Let's say zoom auto, and I'm going to move my graph a little bit. So we can see where it hits the axis when it crosses it. And I'm pretty sure the majority of you is using a Texas Instrument. I use a Casio, makes my life much easier. I'm going to solve for the root, and it tells me that x is equal 10.66 at this point. That is the time that the girl takes to catch the bus. And booyah, that is what we have here as the answer. That's it for the part A.